We'll address the situations that we've seen as we go through some of these notes. So we begin with the following situation. We assume that we have a large block of ice at this point. And this large block of ice is resting on a very level, horizontal, smooth ice surface, such as a smoothly frozen surface of a lake. And somebody's pulling on this block with a 70 Newton force. And the 70 Newton force is applied at a 30-degree angle with some direction that we designate as the x direction. Now that is designated as the x direction here. If there is no friction on this ice, and of course there will be some friction, but let's suppose that friction is really negligible, then whatever the mass of this block is, it will accelerate in this direction with an acceleration of 70 newtons divided by its mass, net force divided by mass. So that if the block is sitting still, it'll just start accelerating along this direction. It'll move slowly and then more and more quickly and more quickly along this direction. Now if it's already moving, let's say it's moving in this direction and we begin applying this force at this point, then that motion will gradually and more quickly curve around toward the direction of the force, although it'll never really reach the direction of the force, as long as the direction of the force remains the same. In any case, this force has some effect on the block, and in this case some effect on the motion of the block. It turns out that this force can be replaced totally by its two components, its x component and its y component. And you know how to calculate those components. The x component is going to be whatever the magnitude of the force is, in this case 70 newtons multiplied by the cosine of the angle, cosine of 30 degrees. That turns out to be something pretty close to 60 newtons. The y component, of course, will be the 70 newtons times the sine of 30 degrees, which will be 35 newtons. The point now is that we could fire the guy that's applying this force and hire two other guys to apply these forces, so that this force can be completely replaced by the combination of these two forces. If we have another force, let's say a 40 Newton force being applied at 115 degrees, at the same time, let's say, as the 70 Newton force, well, we can find the components of this force. Just by multiplying 40 newtons by the sine of 115 degrees, we obtain a 36 Newton y component and a negative 17 Newton x component when we multiply the 40 newtons by the cosine of 115 degrees. So that this force can be replaced by this y component, 36 newtons, and this x component, negative 17 newtons. The situation then looks something like this. We have our 70 Newton and our 40 Newton force acting on the object, and that's equivalent with these angles to a 60 Newton force in the x direction and a negative 17 Newton force in the x direction, and then y direction forces of 35 and 36 newtons, both in the positive y direction. It should be clear that if somebody pulls with 60 newtons of force here and negative 17 newtons of force here, we could simply tell this negative 17 Newton force to go away and tell this one to apply only a 43 Newton force. Or we could fire both these guys and hire somebody to just apply a 43 Newton force. And similarly, that the 35 and 36 Newton forces in the y direction could be replaced by a 71 Newton force in the y direction, giving us a picture like this: 43 newtons in the x direction, 71 newtons in the y direction. Now, if we want to find the equivalent force, a magnitude and direction for an equivalent force, we can simply complete a rectangle defined by these two forces, with these two forces as sides, and draw the diagonal. That force will be equivalent to these two forces. By what we know about tangents, remember the tangent of an angle is the opposite side over the adjacent, and if you don't remember that, You're just going to remember something here. From that, we've determined that the angle here must be the inverse tangent of the y component over the x, the 71 newtons over the 43 newtons. And that inverse tangent is easily found in degree mode in your calculator to be 58.8 degrees. Similarly, we can find the magnitude of the force. There should be absolute value signs around that to indicate magnitude, but the Pythagorean theorem just says we square this, we get the square of this. And using that fact, we end up with the idea that the force is 83 newtons at an angle of 58.8 degrees.